Okay, so we're going to continue talking and building this unit circle. I promise we're getting to it slowly but surely. So in the previous video, we looked at what is a unit circle. So the unit circle is quite literally a circle centered at the origin with a radius of 1, and that radius of 1 is going to be like chef's kiss in just a second. Okay, you're really going to like that. And then we talked about the different quadrant angles. So if you have these quadrant angles, so 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, what point would intersect the unit circle if we drew those angles? Now we want to really focus on sine and cosine, and if we can understand sine and cosine, that's enough for us to build the rest of the 6 trigonometric functions when it concerns the unit circle. Then we'll look at an example, and then I promise we're going to build the unit circle soon, okay? So when it comes to sine and cosine, these are really important because if we know sine and cosine, we can find tangent. And if we know sine, cosine, and tangent, knowing the reciprocal identities, we can build cosecant, secant, and cotangent. Okay? Now, recall, if we have a circle, let's call it the unit circle, and if xy is a point on the terminal side of theta, so you draw some angle, theta, and it has a point on the terminal side, and r is the distance from the origin to that point, then we were able to define sine and cosine as follows. So let me give you a visual reminder. Let's scroll back to the beginning of this worksheet. And right here we said, okay, we have some angle theta that we've drawn in the Cartesian plane. We know that we're going to have some point on the terminal side called xy. Okay, we know that point on the terminal side is going to be a distance of r from the origin. Knowing that, we kind of were able to sort of build this right triangle and remind ourselves of what the 6 trigonometric functions are. So we know that we've got, for sine, it's opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. For tangent, it's opposite over adjacent. We know cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And we know that cotangent is the reciprocal of tangent. And what's most important now that we really want to focus on is the relationship between the angle, the point on the terminal side, and the radius is what it's going to ultimately be, but the distance from the origin to that point. So we know that we can define sine as y over r, and we can define cosine as x over r. So that's what we're saying all the way down here. Okay, so we didn't pull this out of thin air. It's from that first example that we looked at. So we've defined sine of theta and cosine of theta as follows. And remember, if we need to draw just like a really quick example, we can see here that that's where these values come from. Now, what's going to be really phenomenal about this is if we draw this unit circle, we're going to say, hey, we've got this unit circle. We can draw the exact same angle, and it's going to intersect that terminal side of our angle is going to intersect the unit circle. Okay. But when we intersect the unit circle, the distance from the point to the origin is the radius of that circle, and it's going to be 1. Okay, so however, if the terminal side of an angle intersects the unit circle, that's really important, highlight it, underline it, put stars, whatever, then the value of r is going to equal 1. It's really just the radius. So all this time we've kind of been dancing around the fact that r is the radius. We just weren't technically drawing a circle. Now we're like, hey, we've drawn a circle. It's centered at the origin. It has a radius of 1. No matter what angle you draw, it's going to intersect our unit circle. The terminal side is going to intersect our unit circle, and the distance from the origin to whatever point you intersect the unit circle at is going to have a distance of r, okay, which is 1. All right, so that makes this even better because we already know sine is y over r. Well, if r is 1, that just tells me that sine is the y coordinate of that point. And we already know that cosine of theta is x over r, but if r is 1, which we're forcing it to be by drawing this unit circle, then we have that cosine is really the x coordinate. So this is the y coordinate, and this is the x coordinate. And that's really, really, really powerful and nice. This only works on the unit circle though. You have to be on a unit circle where the distance from the origin to the point where you intersect the circle has to be a distance of 1. So you have to have a radius of 1, okay? So then I follow up and I say, thus, for any angle theta, the coordinates of the corresponding point on the unit circle can be defined as x comma y, or really cosine of theta comma sine of theta, because cosine is really our x coordinate and sine is really our y coordinate, assuming you're on the unit circle where r is exactly 1. Okay, so we kind of sum it up right here. We can now say that sine of theta on the unit circle is always going to be the y value of whatever point, like wherever your terminal angle intersects the unit circle, and cosine is always going to be the x value. Okay, so again, this only works if you're on the unit circle. Otherwise, those ratios are going to be different because r is going to be different. Okay, now it says fill in the table with the values of the 6 trigonometric functions when on the unit circle. So on the unit circle, well, we already know that sine is y and cosine is x. Okay, now tangent, we have to go back to the identities that we learned several sections ago. So we had this idea of a quotient identity, and we know that tangent is really sine over cosine. So that tells me that tangent is y over x. Okay. Now, cosecant is the reciprocal of sine, so cosecant would be 1 over y. Secant is the reciprocal of cosine, so it would be 1 over x. And then cotangent is the reciprocal of tangent, making it x over y. And that one shouldn't be too shocking because remember those quotient identities? We had a quotient identity for cotangent too, which said that cotangent is cosine over sine. So x over y. Okay? So those are the 6 trigonometric functions and what they look like according to the ordered pair. So again, this is assuming we have some point xy on terminal side of the angle. And the terminal side is going to intersect that circle at this point xy. Okay? Now let's look at an actual example of this. So we're going to have a point that we're being told is on the unit circle, okay? Let's figure out what sine, cosine, and so forth are. So let's figure out the 6 trigonometric functions if we have the point -1/5, comma, 2 square root 6 over 5. So this is some random point on the unit circle, okay? So if we were to draw an angle, we would have our terminal side intersecting the unit circle at this point, -1/5, comma, 2 square root 6 over 5, okay? Now, we know that sine is really the y coordinate over r, but r is 1, so it's just the plain old y coordinate. So we would say that sine of theta is 2 square root 6 over 5. It's that simple, okay? Cosine of theta, we know, is really the x coordinate over r, but r is 1 because we're on the unit circle. So cosine is really just the x coordinate. So cosine is -1/5. Now, tangent's a little bit more complicated. We know that tangent is sine of theta divided by cosine of theta. So you could try to draw a triangle here, and you could draw a triangle in the Cartesian plane that has this point, and then you could figure out what the third side of the triangle is, or whatever. You could find all 3 sides of the triangle, and then you could find the ratios. But we actually have enough information here. We just want to take 2 square root 6 over 5 and divide it by -1/5. Well, 2 square root 6, whoops, I wrote that wrong. Hold on. 2 square root 6 over 5 divided by 1/5, or -1/5, is really 2 square root 6 over 5 times -5 over 1. Well, the 5's cancel, and that leaves me with, I'm running out of room, -2 square root 6. Okay? And then cosecant is the reciprocal of sine, so we just find the reciprocal of this and then rationalize it. So we know this is 1 over sine of theta. So it's going to be 5 over 2 square root 6, but we want to rationalize, so we multiply top and bottom by the square root of 6. I've told you, I've warned you a few times that you have to be able to rationalize denominators, so please practice this. This needs to be something you can do like real quick, okay? So we get 5 square root 6 over 2 times 6, which is really 5 square root 6 over 12. All right, now secant is the reciprocal of cosine. So that's just going to be -5/1 or -5. And then finally, cotangent is the reciprocal of tangent. So it's going to be, well, we can do it this way. So we have -1/2 square root 6. We rationalize. Then we get square root of 6 over 2 times 6, or square root of 6 over 12. And just don't forget your negative like I almost did. So there you have it. Those are the 6 trigonometric functions. If we know we have the point -1/5 comma 2 square root 6 over 5 on the unit circle. Okay? So in the next video, we will actually fill in our unit circle. So you have the unit circle. We know it's a circle centered at the radius, centered at the origin with a radius of 1. And what we're going to do is we're going to look at really, really important angles that we've already discussed. So we've already discussed the 30-degree angle, the 45-degree angle, and the 60-degree angle. We're just going to put them in this unit circle. So we're going to build the unit circle, and it's going to give us a visual and a tool that's going to make memorizing and understanding those angles much, much easier.